How are you? We meet again in our class, online class for BEE, Principle of Communication. Okay, let discuss something about uh, this topic. Okay, we will discuss a little bit on some calculation in this topic, chapter 1, part 2, gain attenuation, gain attenuation, decibels, and noise. This is uh, very important. Okay, gain, attenuation, and decibels. Okay, you can read this. We have discussed this before. Gain is the ratio of gain, sometimes written as A, is the ratio of output to the input. So A is V out over V in. It should be always output over input. So AV, gain of the voltage, AV is the gain of the voltage. V out over V in. Okay. Okay, so if you have gain of the power, AP, power gain, AP is P out over P input. Okay, so it's always output over input. So here is the example. This is a straightforward example. The power output, the power, so this is the output, 6 watts. So P out equal to 6. The power gain, AP, this one, AP equal to 80. Okay, so what is P in? Okay, so calculation, P in equal to P out over P in equal to 80. Okay, so therefore P in equal to 6 over 80 equal to 75 milliwatt. Okay, you can use your calculator. Use your calculator to calculate. You will get this 0.075 watt, and you change to the unit milliwatt. 1, 2, 3, so 75 milliwatt. Easy, yeah? Easy. If the question in Kalam, normally they give you this, the box, answer box like this, and the unit here. You need to be careful. If the unit is milliwatt, so you need to write here 75 milliwatt. If the unit is, if you see the answer box is watt, so you need to write 0.075. Okay, depends on the unit. You need to be careful what number, what denomination, or what format to be written in the answer box. Normally in Kalam, you you will see the question like this. Okay. Next is the gain. So if you have more than one stage, you will have cascaded. Okay, cascaded means one stage after another. Now you have gain 1, gain 2, and gain 3. Stage 1, stage 2, and stage 3. So the total of all these stages are the multiplication. Okay, so A1 is basically A total equal to A1 multiplied by A2 multiplied by A3. Okay, the loss. Attenuation refers to loss introduced by a circuit or component if the output signal is lower in amplitude than the input. The circuit has loss or attenuation. So basically, it is reverse of gain. Okay, gain is bigger. A is bigger. So you have attenuation. Gain is bigger than 1, it is called gain. Okay, but if it is less than 1, normally it is called attenuation. Output is smaller than input. So there is attenuation. The equation, the concept is similar, where you have out or out over input, output over input also. Okay, less than 1. Okay, meaning if A is less than 1, then A become attenuation. A less than 1 means if V out less than V in. Okay, it becomes smaller. So there is attenuation. Okay, so this is the example for attenuation. Voltage divider. Here in this circuit, this is the output, this is the input. So basically, V out is the voltage divider, voltage division of V in. And the value is depending on the value of R2 and R1. I suppose all of you is familiar with voltage division. So in this case, V out is less than V in. V out is smaller than V in. Therefore, A is the known as attenuation. Okay. In this case, the voltage R2 can be calculated using voltage division rule. So V out is R2 over sum of R1 and R2, R2 over sum R1 and R2 multiplied by V in, V total, V from ground to R1. So you get this V out. Okay, so therefore the attenuation is V out over V in equal to this one. So 0.333. Okay, yeah? So attenuation also same like the previous multiple stage gain, but this time the gain is smaller. The output is smaller. The output is much smaller compared to the input. So the gain is is less than 1, so become attenuation. Okay, so gain and attenuation basically is the same, but if it is more than 1, it is called gain. If less than 1, it is called attenuation. So it can combine gain and attenuation in one circuit. So now you have this one. This is attenuation. A less than 1. Here this is gain. A more than 1. So here again attenuation. A less than 1. And here again gain more than 1. So the result is the sum of uh, multiplication of A1, A2, A3 and A4. Okay, example, an amplifier has gain of 45,000. So this is amplifier. So amplifier, the total gain is 45,000. Which an input voltage, what attenuation factor is need to keep the output exceeding 100 millivolt? Okay, so what is the total? So there is two stage, A1 and A2. A1, A2. So here the input is 20 microvolt. Okay, so here multiplication is 45,000. 45,000. So what is the output? And then you need to reduce so that the output here is 10 is 100 millivolt. Okay, so find A2. Okay, okay, you calculate lah yourself. Okay, for example, this ada jawapan lah. Alamak. The amplifier has 45,000. Okay, so 80 total amplification is, this is 100, this is 100, this is total output. The Vout is 100 millivolt over the input is 20 microvolt. So 5,000, total is 5,000. So using this equation, total amplification is 5,000 equal to stage 1 amplifier amplification multiplied by stage 2 attenuation. So here is 45,000 and what is here, so that you get 5,000. Okay, so using this equation you get the answer 0.1. Okay, next is dB. dB is ratio of the power. Magnitude of communication signals span very wide range, causing drawback as following. So you need very large scale in order to show all the number. Okay, so due to all this reason, we prefer using log scale in order to calculate power measurement. Okay, so what is dB? Basically, dB is a ratio of two power, normally P out and P in. Okay, the ratio, the log of the ratio. Okay, if two power are expressed in the same unit, so this power need to be in the same unit, either it is watt, milliwatt, or whatever. So you just ratio these two number, so you get a dimensionless quantity. So this watt over watt, so you become one ratio. So this ratio, log 10 and multiply by 10. 10 log ratio of the power, same unit. Okay, so P1 is power 1, P2 is power 2, both in watt unit. Okay, so what is dB? dB is the 10 log base 10, this the power ratio. Okay, so basically, gain and loss, as we have discussed just now, is similar. Gain is the positive value. Positive value in dB indicates the output power greater than the input power. So if output greater than input, so this is positive dB. If negative, negative dB indicates the output power less than the input. Output less than input. Okay, output less than input, so this is negative dB. So negative dB is loss. Positive dB is, again, is a gain. Gain or amplification. Loss also known as attenuation. Okay, if it is not negative or positive, where output equal to input, there is case output equal to input. There is no attenuation or no loss. So this is called unity. Okay, unity, meaning the output is equal to input. There is a circuit in electronic where you have unity amplifier. There is some advantage of this circuit to remove noise and so on. So in this case, we call it unity. The power output equal to power input. Okay. Okay, you can see here decibel. Decibel calculation, if you have voltage or current, it is voltage or current, it is 20, right? 20 dB. If you have power, then it is 10 log. Why? Because of the equation. P equal to VI. Okay. So there is some derivation in the equation, so that when you calculate the dB for voltage or current, you need to multiply by 20. Okay, but if you calculate for power, it is only 10. Okay, here there is dBm. When a decibel value is computed by comparing a power value to 1 milliwatt, 1 milliwatt, the result is a value called dBm. Okay, sometimes you see dBm. dBms mean that the decibel is compared to 1 milliwatt. It's compared to the reference value at 1 milliwatt. So it is called dBm. There is some application of this. The similar happen when the value is compared to the value dBc is decibel gain attenuation figure, where it reference is the carrier. Okay, if you compare to the carrier, you have the value dBc, but this one is not that common compared to dBm. Okay. Okay, example. Calculate the ratio of 1 kilowatt or 1000 watt to 1 watt. Okay. So you have P1 equal to 1000 watt, P2 equal to 1 watt. So of course this is 1000. Ratio is 1000. So in dB, we can write like this. Using this formula, you have 10 because this is power, watt. Watt, so you use 10 log P1 over P2. So this is log 10 of 1000 is 3. Okay, 3 multiplied by 10 is 30 dB. Okay, so you can try using your calculator for these two. An amplifier has input. Okay, let's see this equation. One. An amplifier has an input of 3 milliwatt, 3 millivolt, and output of 5 volts. So now you have voltage, right? Voltage. So voltage, now you have the equation is in 20 log blah blah blah. Okay, so amplifier has input, so the input V in 3 millivolt, output voltage V out equal to 5 volts. So the gain for A equal to 20 log V out over V in. So you solve this. V out is 5, V in is 3003. So make sure this value is properly calculated. So you are writing the ratio with the same value, the same unit. So one is 5 millivolt. One is 5 volt and another one is 3 millivolt. So you can write like in volt, unit volt like this, 5 over 0.003 millivolt, or you can write 5000 millivolt over 3 millivolt. You can write like this also can. So here, this value, put it here. So log. So this one become this one similar. So you get this. Okay. Okay. So remember this. I think this one can be our quiz question. So what happen if I make a quiz from this question? What happen is that I will change this value and this value. So you just need to calculate using this equation. So you will calculate the value here. So maybe this question, you get this question, and then the answer is gain. In column we write like this. Gain is here. Answer box, and then maybe you need dB. So here you need to write, for example, 64.4. Okay, it's straightforward, right? But you need to calculate. You need to calculate this. Maybe here 5 millivolt, here maybe 2 volt. Okay, so you need to calculate the value. We change the value here. You and your friend will get different value here. Maybe your friend get 1 millivolt, and here is 10 volt. So you need to calculate here. Okay, and make sure the answer is, you write the answer correctly lah. Normally I will consider two decimal place. Let's say like this, you write 64.40. You didn't, or if there is more number after the point, then you just need to take two decimal point. Okay. Okay. Okay, gain, attenuation, and decibels. Okay, almost the same. The power amplifier with 40 dB, so the answer is given already, has an output power of 100 watt. What is the input power? What is the input power? So you know A equal to output power over P input, right? So sorry, A equal to 10 log. Okay, because of power you have 10 here, 10. Okay, but given already, this is 40 dB. So this is 40 dB gain. Power is 100, so 100 come here. Okay, output power is 100. This one is 100. So solving this for log P out over P in, so you need to do anti-log. So anti-log of 4 is anti-log of this one. Okay, so this is how you manage your calculator. So how you solve this? P out over P in equal to 10 to the power of 4, 10,000. So P in is P out over 1 over 10,000. So blah blah blah. So you get the answer 10 milliwatt. Okay, same. If I have the question for the quiz, if I choose this example, so what happen is you get this number and this number change. So you and your friend may be having different number for this. So what you need to do, just follow this equation, and then you get your answer. The answer may be, what is the input power? So the answer in the column, answer input power equal to the answer box, and the unit is milliwatt. Or sometimes your friend maybe have like this. Okay, this is milliwatt, this is watt. So this is if like this, your answer is 10 milliwatt. If your answer is having the unit watt, so you need to put 0.001, 0.001, or this is 1 milliwatt, right? Sorry. So you need to answer. Sorry. Yeah, wrong. You need to answer 0.01 watt. So you need to be very careful here. Some trick might happen to you. Okay, the question is simple, but answering this is need some careful. So you need to be very careful. Sometimes, you know, lecturer give some trick. Okay, so the next exercise is the receiver have 3 stages. I think okay, one more. M receiver radio has 3 stages comprised of 2 amplifier and 1 filter with an input power P in, blah blah blah. So input phase 1, phase 2, or stage 1, stage 2, and stage 3. Okay, the gain, the dB gain each stage. Okay, so if you have power, remember you need to use 10 log. Okay, output power in dB and watts. Okay, what is the difference between positive and negative decibel? Ada answer? Tak ada. Ini jawapan jawapan dia dah ada. Okay, that's all for this time. We will discuss later about noise interference and distortion for the next part of the video. So that's all. Thank you very much. Okay, hope you understand. Please use your calculator wisely. Try to do some simple calculation before we go to a little bit tougher, not tougher lah. Next stage calculation. Okay, that's all. Thank you very much.